Hello and welcome back. We will continue looking at hypothesis testing in this video, and we'll look at means today. So when you are testing a mean, testing a hypothesis about a mean, there are two different test statistics. The common one is going to be t, and we use t if the population standard deviation is not known. And if we are testing statistics about the population mean, it's because we don't understand what the mean is. And if we don't know what the mean is, we probably don't know what the standard deviation is. So this is going to be the one that we will use most often, t. If we do somehow know or have a pretty good estimate for what the population standard deviation is, we can use z instead. So z comes from a normal distribution. T comes from a distribution that is quite normal. It's very close to being normal, but it allows a little bit more flexibility. So through all this, we have x bar, which is the sample mean, and mu, which is the population mean, which is going to be sort of what we're testing the value of. We have s and sigma are the sample standard deviation and population standard deviation, n is the sample size. And the other thing to know is for the t distribution, we have to know the degree of freedom, and this is going to be n minus 1. So with a larger sample size, we have more degrees of freedom, which means that the t distribution looks more and more normal. So having a bigger sample size means that the t distribution looks more normal. A couple things to remember though, we can only use these techniques for the testing sample means, testing hypotheses about means. We need the sample to be a simple random sample. It can't come from like a clustered sample or a stratified sample. And either the population needs to be normally distributed, or we need a large sample. So if the population is normally distributed, it doesn't matter the sample size. However, if the population is not normally distributed, we have to take a pretty large sample size, at least 30, to ensure that we can use our t distribution. So let's look at an example here. We've got a sleep study records hours slept by 12 randomly selected individuals. So right away, we don't have a large sample size. We don't have a sample size greater than 30, but the sample was randomly selected. So, we'll have to assume that because 12 is not greater than 30, we'll have to assume that the number of hours slept comes from a normal distribution, from a normally distributed population. So one criterion is met, the randomly selected individuals. The other one, we have to assume the normal distribution. The mean, so the hours are listed down here, but the mean is going to be 6.83 repeating, and the standard deviation rounded to 2 decimal places is 1.99. So using a significance level of 0.05, we want to test a claim that the mean hours of sleep is less than 7. So let's go through our process. So the claim is that the mean hours of sleep is less than 7. And when we write this symbolically, for a population mean, we normally would use mu, and we want to say that this is less than 7. So we need to come up with our null and alternative hypotheses. The null hypothesis is always that the mean is in fact equal to this value, so that mu is equal to 7, and our alternative hypothesis is going to be that mu is less than 7. So the potential values or potential alternative hypotheses would be mu is less than 7, mu is greater than 7, or mu is not equal to 7. Well, this is what we're testing here. So we want the alternative hypothesis to be essentially the same as the claim that we're making. The significance level we already said was going to be 0.05. So when we find our p-value, p is less than this, we will reject the claim. If p is greater than this, we will not reject the claim. And now we need to find the test statistic. So the test statistic here is going to be t. It's going to be x bar minus mu divided by s divided by the square root of n. So x bar we said was 6.83. Mu, the value that we're testing, is going to be 7 hours of sleep. S, our sample standard deviation, was going to be 1.99. And n was 12 because we had 12 individuals in the study. So after we plug all these in, we get t is roughly negative 0.29. If we round it to three digits, it's actually negative 0.290. We also need the degrees of freedom here, and that's just one less than our sample size, which is going to be 11. So for our t statistic, for the degrees of freedom, let's go to StatCrunch, and if you open the statistics, go to calculators, down to the t distribution, we want, so here's our t calculator. The reason I'm doing this is to find the p-value, and let's draw a quick video so we'll help understand what's going on. So our t distribution looks roughly normal, and so it'll be centered around 0. So if we come down to negative 0.29, we are looking at a left tail distribution because our alternative hypothesis is mu is less than 7. So we are looking at the area to the left of negative 2.90. So coming back to StatCrunch, we want to look for, so our degree of freedom is going to be 11, and we want the area to the left of negative 0.29. So we get 0.3886. So our p-value is going to be 0.3886, which our p-value is in fact greater than alpha, because 0.3886 is greater than 0.05. So we do not reject, we fail to reject the hypothesis, meaning we fail to reject the null hypothesis. I should clarify. So our conclusion would be that there is not enough evidence to support the claim the mean hours of sleep is less than 7. So we can't quite say, there's just not enough evidence to say that the mean hours of sleep is less than 7. It was for our sample, but maybe our sample was too small. The other thing to keep in mind is that StatCrunch can handle these sorts of calculations itself. So here I have loaded in all of the values for our sample here. So if I come to statistics, we can look at the t statistics. We have one sample, and the difference between with data and with summary, with data, we'll refer to the fact that we have each individual average, each individual data value here. With summary would be if we were to just plug in the average and standard deviations ourselves. So we will do this with data. Our column is just going to be this first column, and we want a hypothesis test. The null hypothesis was that mu is equal to 7. The alternative hypothesis is that mu is less than 7. I'm just going to click compute. I'm not going to change anything else in here. And what we find is that our so our sample mean is exactly what we were told. We have the same degrees of freedom. Our t statistic, negative 0.28977. So this will round to 3 decimal places to 0.290, which is what we found. And our p-value is exactly the same. So since p is greater than since our p-value is greater than our significance level, we fail to reject the null hypothesis, so that there is not enough evidence to support